Thanks for joining me for MTI's Whiteboard Wednesdays. I'm Dan Adams. Today we're talking about which method is best. Which method is best? In previous sessions we talked about how most applications can be welded with any of the friction welding techniques. And the examples that you see here could be welded with other techniques as well, but these are standard rotary friction welding geometries. Typically, there's two important criteria when you're talking about which application you want to use. You have material considerations and you have geometry considerations. For the purpose of this discussion, we're going to consider that the materials are pretty similar to each other so that we can focus on the geometry effects. In the case of a bar-to-bar application, we know that there's no relative motion at the center of a rotating bar. Therefore, all of the heat is going to be coming from the outside of the bar in. So we want a long heating process using an electric motor in order to have that constant energy input. This lends itself to direct drive or hybrid friction welding. Now, small bars can be welded with the inertia cycle without a penalty on load or energy. In the application of tube to tube, this can be welded with any of the techniques for small parts. As the tube gets larger and larger, we may have an issue with torque and an electric motor. So adding the flywheels for the hybrid cycle or using the inertia cycle would lend itself to very large diameter tubes. If we're talking about a tube to bar application, you have the same issue with torque on large parts. So as the tube gets larger and larger, we're going to want to use the flywheels for either hybrid or inertia. Or you can use the direct drive cycle for relatively small parts. There's no center heating issue because there is no contact at the center of the bar. In a bar to plate application, we do have the center heating issue. So direct drive or using an electric motor or the hybrid cycle would work, but we also want to make sure that the plate isn't acting too much as a heat sink. So we want to get the energy in quickly. This one may, for larger parts, lend itself better for the hybrid cycle. If we look at the tube to plate application, this is classic inertia. The plate is going to act as a heat sink, so we have to get the energy in very quickly in order to penetrate that tube into the plate. So this lends itself to inertia, with a second choice being the hybrid cycle. Again, any one of these geometries can be welded with the three welding techniques. MTI offers all three of these technologies so that we can optimize your application for the best possible results. Thank you for joining us for this episode of MTI's Whiteboard Wednesdays. For more information on this topic or other friction welding solutions, please visit our website at mtiwelding.com.